In this video, we're going to review Unit 7 to prepare for the Gateway Quiz and the Performance Task. So starting off, we're going to be using this model to try to determine what kind of bond is being shown. So if you look at this model, Na on the periodic table is on the metal side. So this is a metal Cl. We find that on the periodic table. It's over here on the right side. This is a nonmetal. So we have this structure that has a metal and a nonmetal. That is an ionic bond. And how we know is because Na is a metal / positive ion, and Cl or chlorine is a nonmetal / negative ion. And then 4 characteristics of ionic bonds. Well, number 1, they're made up of metals and nonmetals. They have an electronegativity difference that's greater than 2. So let me write that. Electronegativity difference greater than 2. They break up or dissociate in water, and they conduct electricity. So dissociates, and this was seen in that lab that you did at the beginning of this unit. So dissociates in water, meaning they break up. The NaCl, this structure breaks up into just a bunch of NAs and Cl's ions. So dissociates in water and conducts electricity. And then another characteristic is that the electron is transferred from the metal to the nonmetal. And that can be seen in the models. So electron is transferred from the metal to the nonmetal. All right, next one. We have another model, and we're trying to find, okay, what do all these atoms in this stable molecule have in common? So the way that this is shown is like, this is a 3D model, where the atoms are sharing electrons. So this is a covalent compound. And what covalent compounds do is they share electrons in order to have a full valence shell. And most of these want to have 8 electrons around them. And that is called the octet rule, which is also in your vocab. But pretty much all atoms in this molecule have a full valence shell. So they all like to have 8 electrons around them. There's a couple exceptions, like hydrogen just wants to have 2, but it still has a full valence shell. All right, next one. How many bonds are made by carbon, hydrogen, chlorine? So for this, we're going to use the periodic table. Carbon is, oops, wrong one. Here we go. Carbon is in group 4. So the Lewis dot structure is going to look like this: 1, 2, 3, 4. The single bonds tell you how many, the single electrons tell you how many bonds they can make. So carbon can make 4 bonds. Hydrogen is over here in group 1. So hydrogen's Lewis structure looks like this. It has 1 single electron, so it can make 1 bond. Chlorine is on the other side over here in group 7. So chlorine's Lewis dot structure is going to look like this. and it can only make one bond because it has one single electron. So you're using the periodic table group number to draw the Lewis structure, find how many single electrons you have, and then that's how you figure out how many bonds you can make. The next one, in a molecule containing fluorine and carbon, which atoms tend to pull electrons more towards itself? So let's see, fluorine versus carbon. So here's fluorine, here's carbon. And which one is pulling atoms? Let's see, atoms tend to pull electrons more towards itself. So in terms of electrons, electronegativity trend is increasing going this way and increasing going this way. So since fluorine is further to the right, that one is going to be pulling those electrons more towards itself. So I'm going to write fluorine. And then the Y is because fluorine has the highest electronegativity. Move this value compared to carbon. And you can even, if you have your electronegativity chart, you can actually place those values. So fluorine 4.0 compared to carbon, which is 2.5. And what bond do they form? So if we look at, okay, fluorine is 4, and then carbon is 2.5. If we subtract those, let me see. We get 1.5. And if we compare it to the chart, 1.5 would fall right here, polar covalent. So they would make a polar covalent bond. So you use your electronegativity chart and then you compare it to this scale, and that's how you're going to know what type of bond it's going to form. All right, next one. What is polarity? Must use the words electronegativity and charge. Draw and label any molecule and draw the dipole arrows to explain. Okay, so polarity is when atoms in a bond have an electronegativity difference of 0.4, because that's where the scale starts, causing a partial positive and negative charge. So, for example, if we use the bond from before as an example, fluorine bonded to carbon, since the fluorine is more electronegative, the dipole arrow is going to be facing in that direction. And because the fluorine is more electronegative, it's going to have a partial negative charge because more of the electrons are spending their time there, versus the carbon is going to have a partial positive charge because less electrons are going to be spending their time there. Okay, next one. If an element has an electronegativity of 3.5 and another of 2.5, what kind of bond will they form? So 3.5 minus 2.5, that's 1. So then that falls here in between 0.5 and 2. So this would be polar covalent. All right. Is CaCl2 ionic or covalent? Why? All right, well, let's see. Ca and Cl. So let's figure this out. Ca is over here, Let me go back to this periodic table. Ca is here, so it's a metal. Cl is on this side over here, and it's a non-metal. So since we have a metal and a non-metal, this is an ionic compound. The other way we could figure this out is if we were to take the difference. So remember, there's two ways to figure out if it's ionic or covalent. There's the periodic table method, which we just did, and there's also the math method, which is using the electronegativity chart. So calcium has an electronegativity of 1, which is on here, and then chlorine has an electronegativity of 3. So if we take the difference between them, 3 minus 1, that's 2. And if we look at this chart, that falls right at the border, like here. So in this case, because it's right at the border, but we know we have a metal and a non-metal, we're still going to call it ionic. If it was at this border and we had two nonmetals, then we would say it's covalent. But since we know we have a metal and a nonmetal, given the difference of 2.0 being right at the border, we're still going to go with ionic. Okay. Next one, describe 4 characteristics of covalent bonds. Alright, so covalent bonds, we have non-metal and a non-metal. So only non-metals. The electrons are being shared, so they're not being transferred. Electrons are shared so that they have a full valence shell. That's their goal. And they do not conduct electricity. So does not conduct electricity. And the electronegativity difference is less than, let me clean that up, is less than 2. Because if we look at the scale again, from 0 to 2, that's still covalent bonds, but we have 2 different types, nonpolar and polar. Alright, next one, how many bonds will iodine form? Okay, so iodine, if we look at our periodic table, over here, erase all this, iodine is here, which is in group 7. So iodine's Lewis structure looks like this: 1, 2, 3, 4, 5, 6, 7. It has one single electron, so it can make one bond. What ion will potassium most likely form? Okay, so for ions, on your periodic table, we'll go ahead and label it so it's easier to kind of see the pattern. We did this in the notes, but everybody in group 1 has 1 valence electron, which means they're going to give up that 1 valence electron to have a full outer shell. So they're going to end up with a positive 1 charge. Everybody in group 2 is going to have 2 valence electrons, which means they're going to give up those 2 valence electrons to have that full outer shell. And we're going to skip this middle chunk because they don't follow the rules. We're going to go over to this side. This group here, since they have 3 valence electrons, they are going to end up with a positive 3 charge because they're going to give those 3 electrons away to get a full outer shell. We're going to skip this group here, and then we're going to jump over here. So fluorine, or not fluorine, but this group right here, they're really close to getting a full outer shell of 8 electrons, so they're just going to want to gain 1 electron to get there. So they're going to end up with a negative 2 charge. This group 6, they're 2 away from having a full outer shell, so they're going to want to gain 2 electrons. This group, they're 1, 2, 3 away, so they're going to end up with a negative 3 charge. So I would add that to your periodic table as a quick reference to see like what charges each group has, or they commonly make. Potassium is in group 1, so they're going to end up with a positive 1 charge. Alright, what is formed when salts dissociate? When salts dissociate, they just form ions. So going back to this model, if this dissociates, it's just going to be a bunch of positive and negative ions. Positive sodium ions, negative chlorine ions. Oxygen and silicon form what kind of bond? So again, 2 ways we can figure this out. Oxygen and silicon. So oxygen is over here. It is a nonmetal. Silicon is also here. It's still on the non-metal side. So we're going to have a covalent bond. But let's see if we can get a little bit more specific and see what kind of covalent bond. So let's look at the electronegativity table chart here. So oxygen has 3.5 electronegativity value. Si is 1.8. So if we subtract the two, 3.5 minus 1.8, 3.5 minus 1.8, we get this equals 1.7. And then let's look at our chart. This falls here. So it'd be a polar covalent bond. Okay. Next one. What kind of bond will NaF make, and describe how it reacts in water? Draw the bond. Okay. So Na and F. So again, let's use our periodic table. Na is over here, so that's a metal. F is here, that's a non-metal. And remember, when you're trying to figure out if you have a metal or a non-metal, we're going to use this bold staircase as our guide. So anything to the left of the staircase, that's a metal. Anything to the right of the staircase is a non-metal. The only exception is hydrogen. It's a SPI. It lives on the metal side, but it's a non-metal. Okay, let's use the electronegativity chart just to confirm what we got. So Na has a value of 0.9. F is 4. So 4 minus 0.9 should get 4 minus 0.9, 3.1. And if we look at this scale right here, it is ionic. Okay, so we confirmed using both methods that this is ionic. And now let's draw the model for this. So if we're going to draw a model, or draw the bond model, remember first we're going to start off by drawing the Lewis dot structure. So Na is in group 1, so it's going to have 1 valence electron. F is in, I'll use the other one. F is in group 7, so it's going to have 1, 2, 3, 4, 5, 6, 7. And then the electrons are going to move around here. Okay. We're going to have Na with the positive 1 charge because it lost that electron, and then fluorine is going to have all 8 electrons, so it's going to have a negative 1 charge because it gained 1 electron. And then we're just going to show the attraction between them. And how it reacts in water is, because it's ionic, when in water, or I guess in water, it will dissociate into ions. So it'll break up into the Na plus F minus ions. Alright, so let's go to the next one. What ion will this atom most likely make? How do you know? So for this, we are going to look at this shell. So this shell has 1, 1, 2, 3, 4, 5, 6, 7 electrons. It wants to have a full outer shell. And if you look at the periodic table, chlorine just needs one more electron. So because it just needs one more electron to have a full outer shell, it's going to make a -1 charge. And the reason why is because it has 7 valence electrons and only needs one more to have a full valence shell, and this is going to satisfy the octet rule. Alright, name 2 atoms that will not form bonds, and then why. Okay, so if we look at the periodic table, anybody that is in group 8, everybody here, they have a full outer shell, so they're not going to want to make any bonds because they're already happy. They got all the electrons, all the valence electrons that they need. So I'm just going to pick the first 2. So He, helium, and Ne, neon. And then the why is because, or let me put here, anything in group 18/8A. They already have a full valence shells and don't need to share or transfer electrons. Alright, an atom with 7 outer shells will make blank bond. So let's just put an X. X can be whatever atom. We have 7 outer shell electrons, which means we have 7 valence electrons. We have one single bond, or one single electron, so it's going to make one bond. What 3-dimensional shape will NH3 have? Draw the shape here. Okay, so this NH, so we're going to first draw the Lewis structure, which means we'll list out the atoms. We're going to use the group number. We're going to do our electron count. So the group number, let's see, for nitrogen is 5. For hydrogen, the group number is 1. We're going to multiply this by the subscript to get our electron count. So the subscript is this. We're going to look at the formula. Remember, anytime you don't see a number, it's a 1. So that means we have N1H3. 5 times 1 is 5. 1 times 3 is 3. We're going to add these two numbers together. 5 plus 3 is 8 total electrons. Next, what we're going to do is we're going to draw the Lewis dot structure. We're using the group number to draw the Lewis dot structure. So N is 1, 2, 3, 4, 5 because it's in group 5. H is 1. Nitrogen has 3 single electrons, so it can make 3 bonds. Hydrogen has 1 single electron, so it can make 1 bond. Whichever one makes the most bonds is going to go in the middle, which is nitrogen, since it makes 3 bonds. So I'm just going to copy it exactly the same. And then hydrogen is going to go last because it makes the least number of bonds. Last thing we're going to do is double check that this satisfies all the rules. We have here 2, 4, 6, 8 electrons. Each hydrogen is making 1 bond. The nitrogen is making 3 bonds. So this is the correct structure. So next what we're going to do is we are going to determine the shape of this. So we got to use our chart. We have 1, 2, 3, 4 groups around our central atom. So I'm going to go to this 4th row here. And I'm looking for which of these best matches this model. So I have in this one that I drew, 3 bonds and a lone pair, and it matches this one here. So this is going to be, let me get rid of this. Okay, it's going to be trigonal pyramid, and we're going to draw the shape. So pretty much what we're doing is we're replacing the E with the N, and then the X's are the H's. So that's our shape, our 3D shape. All right, next one is O2 polar or non-polar. How do you know? So we're going to do the electronegativity difference. So we got to use this chart, O and O. So O is 3.5, and the other O is also 3.5. So 3.5 minus 3.5, that is equal to 0. And if we look at our chart, it falls here within this range, so it ends up being nonpolar. And the Y is because we have an electronegativity difference of 0. All right, next one, draw the Lewis structure for CFCl3 with all of its lone pairs, electrons, and bonds. What shape will this have? Okay, so again, we're going to start by doing our electron count. So we're going to do group number first. So let's use our periodic table. Carbon is in group 4. Fluorine is in group 7. And chlorine is also in group 7. All right, and then after this, we're going to multiply by the subscripts, which are, again, these. If you don't see a number, 1, 1. So we have 1 carbon, 1 fluorine, and 3 chlorines. So this is 4, this is 7, this is 21. We're going to add these numbers together. So that would be, let's see, 21, 28, 29, 30, 31, 32 total electrons. We're going to draw the Lewis dot structures next. So since carbon is in group 4, it's going to have 4 single electrons, which means it can make 4 bonds. Fluorine is in group 7, so it's going to have 7 valence electrons, which means it can make 1 bond. And then chlorine is also in group 7, so it's going to have 7 valence electrons, so it can make 1 bond. Whichever one makes the most bonds is going to go in the middle, so that's carbon. And then the other atoms that make the least number of bonds are going to go on the outside. We have 1 fluorine, so I'm going to place that one here. And then we have 3 chlorines. And then I'm going to fill in. And then all my fluorines have 1 bond, my chlorines only have 1 bond, and my carbon has 4 bonds. Last thing I'm going to do is I'm going to double check my electron count. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. So this checks out. So this is correctly drawn. Last thing is just figuring out the shape. Because I have 1, 2, 3, 4 groups around the carbon, I'm going to use that in my chart to figure out what shape this would be. So I'm going to go to row 4. And because all of those 4 groups are bonds, this is going to be tetrahedral. So when I redraw this, I'm going to have my wedge, my dash line, and then my wedge, and then just a regular bond and a regular bond. That's how I draw my 3D structure. All right, next one, same thing, but now we have CO2. So CO, we're gonna do our electron count. So group numbers, let's look at that. Carbon is in group 4. Oxygen is in group 6. And then we're gonna multiply by how many we have using the subscripts. Again, if you don't see a number, it's a 1. So we have 1 carbon, 2 oxygens. So this is 4, 12. We're going to add these together. So we have a total of 16 electrons. Draw the Lewis dot structures. Carbon is in group 4. So it has 4 valence electrons. That means it can make 4 bonds. Oxygen is in group 6, so 1, 2, 3, 4, 5, 6. It has 2 single electrons, so it can make 2 bonds. Whichever atom makes the most bonds is going to go in the middle, so that's going to be carbon. And I have 2 oxygens, so I'm going to add those next, because they make the next number of bonds. But then if we look at this, we have a problem, because right now, carbon is only making 1, 2 bonds, but it likes to make 4 bonds. And then each oxygen is only making 1 bond. And we count the bonds when it's directly connected to another atom. So this is a problem. Second thing is I want to double check that I actually only have 16 electrons. So I have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So I have 4 too many. Remember, each line represents 2 electrons. So what I'm going to do is I'm just going to erase 2. But that still doesn't solve my problem because that carbon and oxygen are not happy right now. So what I can do is I can move these so they're sharing some more electrons. And now this carbon has 4 bonds. Each oxygen has 2 bonds. We have 16 total electrons, so this is good. Next, we're going to use this chart to figure out, okay, what shape is this going to make? This all counts as one group. This all counts as one group. So that's 2. So if I look at that chart here, I'm going to go to 2, and there's only one option. It's going to be linear. So when I draw this, it's actually going to look exactly the same as this. So I'm not going to actually draw it again because that is the structure. But I am going to add the shape, which is linear. All right, that was the last problem. Hopefully you found this helpful, and good luck on your quiz and on your performance task.